Hi, good afternoon, good morning. Thank you for joining us today for the annual webinar sponsored by the Crash Modification Factors Clearinghouse. My name is Karen Scurry, and I manage the CMF Clearinghouse and related activities for the Federal Highway Administration's Office of Safety. Based on the feedback that we got from very likely many of you after last year's webinar, it was very obvious that there was a great demand to hear more about the application of crash modification factors, which led us to this year's theme, Research Meets Practice, Identifying and Applying Crash Modification Factors. We have a great agenda planned for you today, and that'll start with an overview or updates on the CMF Clearinghouse, including an overview of the new search feature that was launched last summer. Daniel Carter, who manages the daily activities of the CMF Clearinghouse with the University of North Carolina, will provide that overview for us. And then Frank Gross with VHB has the very fortunate role to go over some issues and provide some guidance on applying multiple CMFs. And then we're very fortunate to have two state DOT representatives with us today. Ashley Reinkemeyer with the Missouri DOT will talk to us about how she's used CMFs in roadside analysis. And then Jeremy Fletcher with the Florida DOT will talk to us about how they're using CMFs in design exceptions. And then we'll wrap up with a question and answer session. So before we get started with all of that good stuff, please bear with me for a minute as I go through just a few administrative details and the functionality of the webinar software for those of you that are new to GoToMeeting. So if for some reason your computer or web browser freezes during the webinar, don't panic. Just reload the website and log back into the program. Patty, who is also online and handling a lot of the logistical aspects of today's webinar, assures me that you'll be able to rejoin the session. So just reload the website and log back into the program. As an attendee, you should have a control panel in the upper right corner of your screen that collapses and expands by clicking on the arrows. This control panel is also where you'll be able to ask questions during the webinar. Because of the large number of participants online today, all of the phone lines are muted with the exception of the presenters. So we really do want you to ask questions. We encourage you to ask questions throughout the presentation. You can enter them right in that chat pod. If you want to test that out, you can send a little hi note to Patty and make sure that that's working. We'll do our best to address as many of the questions that we can at the end of the webinar during that question and answer session. And those that we don't get to, we'll try to provide written responses and post them to the CMF Clearinghouse websites along with the recording of today's webinar.
So as Karen said, we're going to go through this agenda she laid out. So I'm going to kick it off by talking about the CMF Clearinghouse website, which I assume many of you have visited and perhaps used. The webinar that we presented last year gave some of the basics about what does the clearinghouse contain, what information's in there, how do you use it. And what we wanted to do this year was give you an update on some of the new functions that we've implemented this past year, some of those in response to input from users like yourself. And so just wanted to kind of give you a brief rundown on that. So give me just a second, I'll pull that up. All right. If you have visited the clearinghouse in the past several months, you've probably seen the sort of new look to the front page, a little bit of a new look. So some of the things that we've done was to simplify the searching. It's all done from this front page. We don't have the separated simple and advanced searches anymore. So this is kind of your one-stop place to go to start the search. We've just got the single box there. And then only one choice here in the pull-down. We've kind of simplified some things. And so when you search whatever term you're putting in, you can specify what field in the database you'd be searching with that. So by default, it's on countermeasure name. That's the one that was most applicable to our users. And so if you search for rumble, it would look for rumble strips in the countermeasure name. The other things you can search for if you want to, if you pull these down, would be the study abstract field. This is you've got a word that could be related to treatment you're looking for, might be in the abstract of a study. That might be a place you'd want to look. Study citation, so that, every entry in the clearinghouse is based on some study, and so you can search that citation specifically if you're interested in a particular journal, or a lot of times if you're interested in a particular author and you're looking for something they've done, you can put the author's last name there and search the citation field. The next one there, the single CMF ID, this was some of the feedback we got from users said, I'd like to give the indication to someone that I've used a particular CMF and direct them as to how to get to it again. And so each CMF has an ID that's made available on the details page and on the Excel download and the printouts for the PDF. And so if you've got a CMF that you've used for a particular project and you want to refer to someone to it, if it's CMF, let's say 188, you can select that single CMF, put in 188 as your search term, and it'll take you right there and give you one result. And then if you really want to get a wide search, if you want to kind of start with a larger net, you can search all those fields together. Some of the other revisions and some of the more major revisions we did took place actually in the search results after you do a search. So I'm just going to kind of do a demonstration search here. If I'm interested in something to do with edge lines and want to find some CMFs related to that, I'm going to keep with countermeasure name as my search option there. The biggest thing you'll see is that we've added filters on this left-hand side, and so this was a way of allowing people to start with an initial search, like edgeline, and then if you get a number of results, which I do here, I've got several hundred, to be able to kind of narrow that down based on what particular situation you're dealing with, what topic you're interested in. The first one we sort of leave expanded to show people that these do expand and collapse, and so that's the star quality rating. If you're familiar with Clearinghouse, we give quality ratings to all the CMFs based on basically how much reliability was behind the development of that CMF. So how bias-free was the study, how much sample did they use, this sort of thing. 5 being the best star rating. And so you'll see here it's telling me of the results that were found from my edgeline search. One of them was a 1-star, 19 were 2 stars, and so on, and 8 of them were 5-star CMFs. This also gives you the indication of sort of what the distribution is of the results that you're seeing. You can go on to expand other filters there, for example, crash type, and you can kind of get a look here to see, okay, of all these CMFs that were returned from my edgeline search, 108 of them were for addressing all crash types, sort of more generally, but 3 of them were for addressing cross-median crash types specifically, 6 of them for daytime crashes, 5 for fixed objects, and so on. You can then check that box and filter, and you go down and hit submit, and that'll sort of filter you down to only see, for example, the CMFs that were dealing with cross-median crashes. The other ones that are listed there, crash severity, roadway type, area type, these are things particular to the application that you're dealing with. The intersection type, if you have different types of intersections you're interested in specifically, 3-leg, 4-leg, the traffic control of those intersections, and then if you're interested specifically in whether a CMF is in the first edition of the Highway Safety Manual, we've got that filter as well. Let's see, I want to go ahead and demonstrate a few other things in addition to the filtering that we did. I'm going to expand this one here to show you. Let's scroll to this one here. If I'm interested particularly in the install wider edge lines, 4 to 5 inches, one of the things we added here was the visible comments field, and this is something that's been in the Clearinghouse since its launch, but something that hasn't been quite as prominent. But basically, this is a way of us as a Clearinghouse team giving you a little bit more information specifically about particular CMFs. A lot of times, study authors will have very specific criteria that they applied in developing one or more of their CMFs, and a lot of times we feel this is something that you really want to know about. For example, some of these CMFs here dealing with installing wider edge lines, we can see here in the comments field to the right that these crash types were excluding intersection and interchange crashes, and it gives us an indication that there's actually more to that comment. So if I'm interested in that first CMF, I can click here to read more. It'll take me to the details page for the CMF, and it actually will jump me down to the bottom where that comment is, and I can see that that CMF value was based on excluding intersection interchange crashes. It was based on winter month crashes, or excluding winter month crashes and animal crashes. So it's a bit more information that might be relevant to the situation that I'm dealing with. And then I just want to mention one more thing that is still available as a result of the revisions we did in the clearinghouse, we still wanted to make available the Excel download. And if you're not familiar with that, basically when you do a search, as I did on Edgelines, I got 354 CMFs, which is a pretty fair number of CMFs, and it's probably going to take me some decisions to go through there and narrow down to exactly what I want to use. If you scroll to the bottom, anytime you do a search and you get a search result, you can export all the results to Excel. And this will bring it to you in an Excel file. And I'll just give a quick show of what that looks like. So then it gives you everything, every CMF that was delivered, those 354 CMFs there, and it provides the fields that we have in our database if you want to do some more filtering, analysis, maybe some tables, or however you want to do it. We want to make that available to you if you are an Excel person. Okay. Some of the other things we instigated as a result of some of the input we got from users was some additional help messages in response to people's searches. So sometimes people search for something and maybe about the way they searched or the search terms they put in, perhaps the clearinghouse doesn't have CMFs for that particular topic or that combination of search terms. For example, if I put in, I'll just do a nonsense one. We don't currently have any CMFs related to bananas, so gap in the research maybe, but you see that I've got 0 CMFs returned for my search results, and then it gives some additional guidance about why maybe I got 0 CMFs in results. So maybe I used too many search terms, and so the advice is use fewer search terms, or perhaps use the search term that refers to a countermeasure name. So basically trying to give some more guidance to people on various ways that their search might end up. The other thing that could possibly frustrate people if they run into it would be the situation where someone is using those filters on the left-hand side and perhaps getting to a situation where they've over-filtered. So just to give an example of what that looks like, if I do a search on chevrons, as I have done here, and I see, okay, I've got these 84 results, and I know that for whatever situation I'm dealing with, I'm really interested in nighttime crashes only, and I'm only interested in fatal crashes. So I want to see the CMFs for nighttime fatal crashes. So I click both of those, I hit filter results, and the help message says I'm not seeing any CMFs now because I've applied too many filters. So basically there weren't any CMFs out of those 84 that fit this criteria, that were both nighttime focused and fatal crash focused, fatal crash specific. So the advice is here, take off one or more of those filters and try it again. And I want to demonstrate one more thing about the filters, and particularly one thing we anticipate being an advantage in sort of the field knowledge and the usability of CMFs from the clearinghouse. And I'll demonstrate that by searching for roundabouts. So I've got 134 CMFs on the roundabout, and I'm just going to kind of go to one specific countermeasure. You see that we've got them collapsed by category. And if you give me just a second, I'm going to go down here. Okay, let's say I'm interested in this one particular countermeasure of converting an intersection with minor road stop control to a modern roundabout, and it's got a fair number of CMFs listed under those. The first one's there, 5 stars, and the latter part of that list right there we can see 4 stars, so some pretty good qualities here. One other thing to notice about these is that they have this superscript down here in the brackets of a B. That's an indication that these CMFs appear in the first edition of the Highway Safety Manual. And the B would be that they appear in that publication in a bold font, which was an indication of the highest quality level in the HSM. We felt that was good information to supply to users. So just a sort of a side note, that's what that is. But if I go here and I see that I've got these various CMFs, and they range pretty well, 0.56, 0.18, down here to 0.71, so there's a pretty wide range of CMF values. But it really bears looking at what is the applicability of these. So they address, all of them here address all crash types. So they are general about the crash type, but crash severity does differ. This one is for all crash severity in all area types. This one is for serious and minor injury. And if we go to area type, we can start seeing the differences now. The third one down starts to focus just on rural areas, and then below that we see focusing just on urban areas. The thing that we would like to help people avoid is using a CMF that doesn't apply to their particular situation. So if someone were to see this list of CMFs, they might think, well, how am I going to decide which CMF to go with in my particular analysis? But it bears looking about what exactly the situation is they're dealing with. So in this scenario, I'll postulate that someone is coming here dealing with an urban area, and if they're perhaps not really paying attention over here to the area type field, sort of more focusing on the left-hand side, they might see a 0.56 and maybe this 0.29. And then the 0.29 looks like it's got some pretty good crash reduction. That's maybe tempting to use. I don't know if it's the best one to use, but it seems pretty good. It's got a 5-star rating. But if I were to look over here, I would say this is for rural areas, and so it doesn't apply to this urban situation, my urban site. What we were hoping to get at is that people would, in using the filters, come over here and kind of start to specify, seeing that they got 134 results, try to narrow that down some using the filters. And so they hopefully come over here and in the area type, if you're dealing with an urban area, check the urban ones if I know that I'm dealing with that specifically. And I can filter those down. We'll get a smaller list. As you see here, even a smaller list of the countermeasures themselves. So if I expand that same countermeasure that we had before, I am seeing fewer. I'm not seeing that 0.29 that dealt with those all crash severities in the rural area, and I'm left, if I'm looking at those all crash severities, with a 0.71, which would be more accurate based on this study, a better CMF to use for an urban area. I'll mention this as an aside. There are other things that make one CMF differ from another. As you can see, the first one and the third one look to be the same based on the fields that you see here, but there are more fields available, more things that make them different from one another. If you click the CMF itself, that's a link, and it will take you to the details page for that CMF, and you can see a lot more information about how that CMF was developed, specifically what types of roads it was developed on, and sometimes one CMF can differ from another just inside here, even down to one was developed in one state and one was developed in another. So there's a lot of different things that you really need to kind of delve into when you start to pick a specific CMF. Sometimes, if you want to, the Excel download can be helpful with that. Okay. If you have any questions, just want to remind you that you can put those into the chat box, and we'll accumulate those, and the ones that we can address during the question period, we will. And for the others, we'll take those offline and put some responses down and then send those back out to everyone. All right, well, we're going to move on to the second presenter, who's going to be Frank Gross. Dr. Gross is a member of our CMF Clearinghouse team. He's one of the reviewers of CMFs in the Clearinghouse. He's going to talk to us today about the topic of if you have a site where you're applying multiple countermeasures, which does happen in a number of situations, and the question comes up of, well, then what CMF do you use for this combined countermeasures? So, Frank, we'll go ahead and hand it off to you.
All right, thanks, Daniel. Welcome, everybody. I think that this is a very timely topic. I'm happy to present on it today. And just as a little bit of background, we'll talk about an ongoing research project that's trying to add some additional information to this issue. But I want to talk a little bit about estimating the combined effect of multiple treatments and some of the issues associated with that. So I'll cover briefly the problem at hand and what we're trying to accomplish, and then I'll spend most of the time talking about a little bit of practical guidance and going through an example application, and then I'll wrap up with some future and ongoing research on the topic. So what is the problem at hand? Basically, what we're trying to do is estimate the combined effect of multiple treatments when we're contemplating installing or implementing multiple improvements or countermeasures at a single location. And those of you who are familiar with the CMF Clearinghouse will quickly point out that most of the 3,000 plus CMFs that are available relate to a single treatment. So one way to estimate the combined effect is to have a CMF for combined treatments, but most of the available CMFs are for single treatments. So is there a way that we can use those CMFs for individual treatments and use multiple CMFs perhaps to estimate the combined effect of multiple treatments. Other ways to go about this, if you wanted to estimate the combined effect, was develop CMFs for combinations of treatments. So in the photo you see here, this is an example of combination of centerline and edgeline rumble strips. So for some countermeasures in the clearinghouse, there are CMFs for combinations of treatments, but it's expensive and not feasible to produce or develop CMFs for all possible combinations of treatments. So how else can we get at this question? The other option is developing guidance for applying multiple CMFs. And I'll say that the current research is very limited. I'll talk a little bit about the Highway Safety Manual and the method that they suggest. But other research is in progress. The NCHRP project shown here, 1763, is just kicking off. Daniel Carter is our principal investigator, and I'm involved with that project as well. There's a number of researchers involved in this project, but you can see that the completion date is anticipated for February of 2016, so still a couple years out. So what can we do in the interim? And that's what I want to talk about next. So I'll talk a little bit about the practical interim guidance before this research project is completed. And really what I want to focus on is the issues underlying the effects of multiple countermeasures or multiple treatments. So it's important to be mindful of the issues, and there's a few different documents that discuss this, but I'll focus on three of the key issues, being added benefits versus additive effects, the assumption of independence, and the applicability of CMFs. So I'll go through each one of these in detail, discussing the underlying issues, and then we'll get into maybe some guidance that you can use to overcome those issues. So first, talking about the added benefit versus additive effects. We would expect additional treatments to have some added benefit, but the effects of those treatments are not additive. So in this case, 20% reduction plus a 20% reduction, say those are the reductions associated with two different treatments, probably is not equal to a 40% reduction. And if you think about a more extreme case, perhaps you have three different countermeasures that you intend to apply or implement. Perhaps each of those three countermeasures is expected to give a 50% reduction in crashes, and if you added up 50 plus 50 plus 50, it's not physically possible to get 150% reduction in crashes. So be mindful that we do not add together the effects of treatments, and I'll get into how we account for that later. But that's the added benefit versus additive effects issue. Another issue is the assumption of independence. So oftentimes you have multiple countermeasures to select from, and if you implemented two or more of those countermeasures, perhaps they're addressing some of the same crash types. And if they are, those treatments are not independent of one another. And in the photo you see up at the top, this is a roadway, and perhaps there was a runoff road issue here. So the agency was faced with a number of options. One option for addressing runoff road crashes is to install shoulder rumble strips. So that's what was selected and done here and shown in the photo. Another option may have been to widen the shoulder along the corridor, and that would help to provide more recovery room. And then a third option may be to widen the shoulder and install the shoulder rumble strips. But shoulder rumble strips and shoulder widening are very similar in terms of the crashes that they would hope to mitigate. So if both treatments were applied, you can see the CMFs at the bottom of the page here. The CMF for installing rumble strips is 0.85, and the CMF for shoulder width or shoulder widening is 0.86. If you applied both of those treatments, would you expect the full effect of each? And the answer is likely no, if they are addressing the same types of crashes. And there could be different variations of that. Maybe two treatments complement each other very well and have a greater effect together than either one would individually if you were to use the individual effects. So there's a number of issues associated with independence, and we just have to think about how related two or more countermeasures are if we're applying two or more. And then the third issue that I want to talk about, and Daniel mentioned this in his overview, so I won't spend a lot of time on it, but it's the applicability of CMFs. And CMFs can apply to different scenarios. So as Daniel was showing, some CMFs may be very specific to a rural or urban area type. Some CMFs apply to specific crash types or crash severities. And if you had two CMFs, one for two different treatments, and one applied to total crashes and the other applied to fatal crashes, it would be inappropriate to multiply those together. So there's different ways to handle that, but it's important to recognize that if CMFs apply to different crash types and severities, it's not appropriate to multiply them together. So let's talk a little bit about how to overcome these issues now. So we talked a little bit about the issue of added benefit versus additive effects, and the Highway Safety Manual uses a multiplicative form. So they estimate the combined CMF as the product of the two individual CMFs. So you're not adding the effects, but rather the CMFs are multiplicative. So going back to our example, if you had two treatments and the crash reduction factors were 20% apiece, the combined result is not 40%, but the CMFs multiplied, 0.8 represents a 20% reduction, so 0.8 for treatment 1 times 0.8 for treatment 2 equals 0.64, and that's a 36% reduction, not a 40% reduction. So in this case, if you use this type of form, multiplicative form, you're not going to estimate crash reductions that would reduce the number of crashes more than the number of crashes that are there. So you can't have more than 100% reduction in crashes. For the assumption of independence, I'll talk a little bit. We have a couple of slides on the assumption of independence and how to overcome that challenge. But the first is to figure out whether or not the assumption is valid. So this requires some judgment on the engineer's part. So I found the easiest way to do that is to list the two treatments side by side and simply list all of the crash types that are associated with those two treatments. So for treatment 1, perhaps you're intending to or contemplating installing lighting at an intersection, and you would list all of the crash types that would apply that may be reduced by installing lighting. And maybe your second treatment is upgrading the signing or adding additional signing at the intersection, and you could list all of the crash types that would be associated with that treatment. And depending on how much overlap there is between the two, you could quickly see whether or not that assumption of independence is valid. So maybe if there's just one or two crash types that overlap, and perhaps you haven't even had a history of those types of crashes, then maybe the assumption of independence would hold. And if you decide that the two treatments are fairly independent, then it may be acceptable to simply multiply the two CMFs together, again assuming that they both apply to the same crash type and severity. If on the other hand you determine that the assumption of independence does not hold, then you might want to temper the effects of the additional treatments. And here's one way to do that, and there's a number of ways that this could be modified. But basically what you're saying is that the combined CMF is equal to the CMF for, say, the most effective treatment, treatment number 1, times a modified CMF for treatment number 2. So the first equation here includes that modified CMF for CMF number 2, and to compute that, it's done in the second equation here. And basically what it's saying is that we're not assuming the full effect of treatment number 2. So if you assumed, or say the CMF for treatment number 2, CMF number 2 is 0.8, a 20% reduction in crashes, maybe we assume that that modified CMF is maybe a 10% reduction in crashes. So maybe we use 0.9 instead of 0.8, and we just assume a slightly less effective treatment or effect for treatment number 2. So this second equation would be cutting the effectiveness in half, basically. Again, using this type of functional form, CMF1 times CMF2, it assumes that both CMFs apply to the same crash type and severity. And also, if you do choose to use this type of method where you temper the effects of additional treatments, I would very strongly encourage you to be consistent. So if you have multiple regions within your state, if you're a decentralized state and you have districts or regions that are submitting applications applying CMFs, make sure everybody's doing that consistently, because if some are assuming a less effective treatment number 2 and others are assuming the full effective treatment number 2, then if you are comparing funding applications, say for the HSIP program, then you're not going to be comparing apples to apples. So consistency is the key to using, some type of tempered method. The last opportunity to overcome challenge is going back to that applicability of CMFs. So again, only multiply CMFs if they apply to the same crash type and severity, and if you feel that those two CMFs are truly independent. You don't always have to multiply two CMFs together, though, to get a combined effect. So really what the ultimate objective is to figure out what the combined effect is of the multiple treatments. So why not evaluate the treatments independently? So if one CMF applies to total crashes and the other CMF applies to maybe fatal and injury crashes or a specific crash type, don't multiply them together, but rather evaluate those separately and then combine the results at the end. So if you figure out that treatment number 1 is going to reduce a certain number of crashes and that's associated with a certain dollar value or benefit, and treatment number 2 has a certain benefit, go all the way through the calculations, compute the dollar value of the benefit, and then combine the dollar values together, because those dollar values are in the same terms. So total crashes and, say, right angle crashes, they're both crashes, but they're different crash types, so it's not appropriate to combine those benefits yet. But if you get all the way through the calculations and compute a dollar value of the benefit, then you could combine those two numbers. And that's where I want to spend a little more time, is with an example application. So this is a quick example, but let's say we have a kind of a split T intersection here, minor road stop control, so the north-south is uncontrolled, that's the main line. The two side roads are both stop controlled. You have a bus stop on the corner here, kind of sidewalks along a couple of the sides of the roadway, the main line, and there's a crosswalk to get between the two sidewalks and to access the bus stop. Some of the safety issues that were identified at this location were exposure for pedestrians. So pedestrians had a relatively wide cross-section to negotiate, 2 lanes plus the median, so that was extending their time in the roadway. The vehicle speeds along the road were a concern. It's a posted speed of 35 miles per hour. The average speeds were in excess of 40, and the 85th percentile speed was closer to 45 miles per hour, so vehicle speed was a concern for pedestrians. Driver awareness was another concern. There were not a lot of signs or indications of pedestrians in the area, other than the presence of the sidewalks and the relatively faded crosswalk. And driver behavior was also a concern. Drivers using this striped median area, painted median, as a kind of an unofficial turn lane to access this relatively unused minor road. So there were a number of issues to deal with, and we're contemplating a couple of suggestions. One would be installing a pedestrian refuge island to help pedestrians kind of perform a 2-stage crossing, provide a little bit more awareness for drivers that pedestrians may be present. You could install some or incorporate signing with this pedestrian refuge. And also a median island on the northbound approach to prevent vehicles from using that painted median as a turn lane, and combine the two islands are kind of acting as traffic calming through the intersection as well, hopefully raising driver awareness as to the presence of the intersection, the potential presence of pedestrians, and maybe help to control speeds a little bit through the area. They're not really the same treatment. They're kind of working together, but we wanted to estimate the combined effect of those two treatments. So what I've presented here in this table are the two strategies, the pedestrian island being the first one, and the raised median island is the second, and that second raised median island is more for traffic calming rather than pedestrian safety. So for the first strategy, we found a CMF in the clearinghouse for installing a pedestrian refuge island. That CMF is 0.54. It applies specifically to pedestrian crashes. There was not a specific CMF in the clearinghouse for installing a raised median island to, say, discourage drivers from using a painted median. But there was a CMF in the clearinghouse for installing channelizing islands as traffic calming devices, and the CMF associated with that treatment was 0.68, and that applied to total crashes. So right away, we recognized that they applied to different crash types, and it would be inappropriate to multiply those two CMFs together to estimate the combined effect. So what I've done is tried to lay this out as two analyses in parallel, and then once we get to the end of the computations, we can combine the results at the end to estimate the combined impact. So for those who are familiar with applying CMFs, a quick and dirty way of figuring out what the impact would be is to take a look at your maybe 3 or 5 year crash history and estimate the average crashes per year based on that 3 or 5 year average, and that would be your estimated crashes in the future if you did nothing. So that's the expected crashes without treatment is your total crashes in the last 5 years, say divided by 5, is 0.2, so we would expect 0.2 pedestrian crashes. And for total crashes, we had 11 crashes in the 5 year history, and that 11 includes the pedestrian crash because we're looking at total crashes. 11 divided by 5 is 2.2 crashes per year, and then multiplying each of those by the respective CMFs, the expected crashes with treatment would be 0.11 and 1.5 respectively, for a reduction in pedestrian crashes of almost 0.1 pedestrian crashes per year and 0.7 total crashes per year. But applying some engineering judgment, we've already kind of taken care of the pedestrian crashes with this first treatment, and now we're including that pedestrian crash again in the second treatment. So, you know, we've decided it may not be appropriate to double count here. So what we've done is rerun the analysis, and instead of looking at total crashes including the pedestrian crash, we've excluded that pedestrian crash from the analysis of the second raised median, since we're accounting for that already with the first treatment. So in this case, we assume that there's 10 crashes per year instead of 11 10 crashes in the 5 year history instead of 11, for an average of 2 crashes per year, and now we're estimating a reduction of 0.64 crashes per year instead of 0.7. And it may seem minor here, but if you get into other analyses where it's a horizontal curve and maybe you've applied one treatment that's addressed a number of runoff road crashes, and maybe you're not going to include all of those runoff road crashes for the second treatment. So I'll just carry this through to the next step and show how you would combine the results in the end. So what I want to do is focus on the 0.09 pedestrian crashes and the 0.64 total crashes, and I'll only carry those two forward. So again, I'm repeating the 0.09. I think that this should be the 0.64 instead of the 0.7. But if you had the average cost of a crash for the two scenarios, multiplied that by the number of crashes reduced per year, you would estimate an annual benefit for the two scenarios. If you factored in the 10-year service life, you could estimate the present value of those two treatments. And then combining the present value, now everything is in the same terms, and we would estimate a combined effect or a combined benefit of almost $270,000, and then that could be compared to the cost of the total construction and maintenance cost of those treatments to estimate your benefit cost analysis. So I guess what I would get at here is that rather than trying to combine CMFs early on, if the CMFs do not apply to the same crash type and severity, perhaps carry through the analysis using those CMFs separately and then combine the results at the end for a combined dollar value rather than trying to combine the CMFs or the number of crashes or the reduction in crashes. So just real quick on future research, again, the NCHRP 1763 study is looking into providing guidance on if you did want to combine CMFs, is it appropriate to adjust maybe the second and third CMFs for multiple treatments to account for those overlapping effects? And some other research that's needed that's currently lacking is guidance on estimating the standard error for the combined effect. So currently, there's no real guidance on estimating the certainty if you combine multiple CMFs. So each CMF has a certain standard error associated with it, telling you how much confidence you would have in your results. And when you multiply 2 or more CMFs, you're introducing more and more uncertainty. So how much uncertainty would be associated with that final result? And that's a matter for future research as well. So those topics, among others, are being covered under the 1763 project, and we would expect the results in the next couple years. But hopefully this presentation has provided you with a little bit more information that you can use in the interim. So with that, I'll say thank you and turn it back over to Daniel, as I understand we'll be taking questions at the end.
Great. Thank you, Frank. Appreciate the look at the realistic issues involved and some real practical interim guidance. I'm sure that's very much appreciated. We're going to go on to Ashley Reinkemeyer from Missouri DOT. And just I'll go ahead and mention while we're switching over control, if you've got questions, and some of you have already availed yourself of this opportunity, but do put them in the chat box, and we'll be taking those, and we'll have some time at the end for answering some of those questions, and the ones we don't get to, we'll give some written responses to and send those back out and post this on the website for everyone later on. So we'll go ahead and hand things off to Ashley. I think you've got the screen control, so please take it away, Ashley.
Hello, everyone. I'm going to give an example today of using CMFs in roadside analysis of what we've done here in Missouri. Before I get into an example of what we've done for a 2-lane rural road, I just want to kind of give some history of what we do in Missouri on our 2-lane roads. If it's considered a major 2-lane road, we are by policy already adding 4-foot paved shoulders with centerline and edgeline rumble stripes. But we had a designer in our office that was curious to know on our 2-lane minor roads, so not the major roads that already have a policy to add the shoulders and rumbles, but for a 2-lane minor road, if we added a 2-foot paved shoulder and centerline and edgeline rumble stripes, he wanted to see what that would do to safety. So in other words, what happens to safety when you pave a shoulder, add your centerline and edgeline rumble stripes, and at the same time, we're steepening that side slope by adding that shoulder for within the existing right-of-way. So for our example, we did make some assumptions that, well, with this example, we're also using the Highway Safety Manual to predict the number of crashes for existing conditions and for the proposed conditions. So by using the Highway Safety Manual, we did make some assumptions for the volume, the lane width, grade, driveway density, and etc. But those are all relative to one another between both alternatives because they are the same. So the only difference between the existing condition and the proposed condition will be our shoulder type, the centerline and rumble stripes, the edgeline rumble stripes, and side slope. So whenever we wanted to do this analysis, to get our CMF for the edgeline rumble, for those of you who are familiar with the Highway Safety Manual, the base conditions, there is a CMF in the Highway Safety Manual for the centerline rumble strips. But there currently isn't anything in the Highway Safety Manual for edgeline rumble strips. So from a federal highway training that we had back in like 2009 or 2010 from Federal Highway, they had given us that the edgeline rumble CMF is 0.87. And so whenever we did this analysis, that is the CMF that we used for the edgeline rumbles. There is probably some more updated or more modern research for edgeline rumbles, but at the time that we did this analysis, we used the 0.87 for the CMF for the edgeline rumbles. And the Federal Highway had actually got that out of the CMF Clearinghouse. And for those of you who are familiar with the CMF Clearinghouse and the Highway Safety Manual, that every CMF that is in the Highway Safety Manual is also in the Clearinghouse. So moving on to steepening the side slope, this is where we had to make some assumptions as well. In the Highway Safety Manual and as well in the CMF Clearinghouse, as I mentioned before, every CMF that's in the Highway Safety Manual is also in the Clearinghouse. But in the Highway Safety Manual, Volume 3, Table 13-18 gives you a variety of CMFs for the potential crash effects on total crashes on flattening your side slope. And as you guys know, as I mentioned before, that by adding that shoulder and paving that shoulder, we're steepening the side slope. So in the Highway Safety Manual, there currently is no CMF for steepening the side slope, or actually if you go out to the Clearinghouse, there is no CMF for steepening the side slope. It's just for the flattening the side slope. So this is where we made some assumptions. The designer who was wanting to do this analysis, this generic analysis, we went to the Highway Safety Manual to the table for flattening side slope, and he was assuming that we were going to go from a 1-inch vertical, 3-inch horizontal, to a 1-inch vertical to a 2-inch horizontal. So we're steepening that side slope from a 1 to 3 to a 1 to 2. But in the Highway Safety Manual, since it's flattening, we made the assumption that if we assumed a side slope in the before condition of a 1 to 2, and we were going to flatten that to a 1 to 3. But if you look at this table, you'll see that there is no condition from going from a 1 to 2 to a 1 to 3. So we made the assumption that on this first line, that each of the CMFs increased by 0.03 all the way across. So for a 1 to 2 to a 1 to 3, which would fall like right here, we assumed that the CMF would be 0.97. So since this was for flattening the side slope, we did some checking around and some questioning and asked if it would be okay to do this, and we actually took the inverse of that 0.97 to get a CMF of 1.03 for steepening the side slope from a 1 to 3 to a 1 to 2, which in your head that kind of makes sense. Whenever if you're steepening the side slope, your crashes in your head you would think would go up, and so our CMF greater than 1 proved that fact. So with that being said, we went to the Highway Safety Manual for a Rule 2-lane road to predict the number of crashes on the Rule 2 lane, and we made an assumption. Well, if you look on the first line up here, we have a length of a segment of just 10 miles. It's just a generic comparison for across the state, and we have a generic volume of 2,000 cars per day. And so for the existing conditions, we have the 2-foot turf shoulder on the left side and the right side, and the center line rumble strips are not present. And then whenever you go through the calculation with the Highway Safety Manual spreadsheets, you get a CMF for your shoulder width and type of 1.19. You get a CMF for your center line rumble strips of 1, and again, this is the existing condition, so no center line rumbles are present, so that's a CMF of 1. And then you come up with a combined CMF of 1.448. And whenever you multiply that times all of your, this is your crash severity level for, because we're dealing with total crashes, you come up with a predicted number of crashes for existing conditions to be 7.736. And so again, this is for a Rule 2-lane road with no paved shoulder, and it does not have center line or edge line rumbles. So now moving on to the proposed condition, again, it's the 10-mile segment with 2,000 cars per day, but now we're going to pave that 2-foot shoulder on the right side, and we're going to pave that shoulder, that 2-foot shoulder on the left side. And in this situation, the center line rumbles are present. We're going to go in and add those center line rumbles. And with the Highway Safety Manual, you get a CMF by adding or paving that shoulder of 1.17. You get a center line rumble strip CMF of 0.94. So we're reducing our crashes by 6% by adding that center line rumble. And then with the Highway Safety Manual, there currently is no CMF in the spreadsheets for your side slope and your edge line rumbles, because it's not considered as one of the base conditions. So we added that CMF that we came up with earlier by taking the inverse of flattening the side slope, and we got a 1.030 CMF for steepening the side slope. And then for your edge line rumbles that we got from Federal Highway, the CMF was 0.87. And so basically you multiply all of those CMFs together and you come up with a predicted number of crashes to be 6.394 for the proposed conditions of a rural 2-lane road with a 2-foot paved shoulder with centerline and edgeline rumbles. So in conclusion, the existing condition with no paved shoulder and no centerline or edgeline rumbles, we were predicting 7.736 crashes per year. And that's total crashes and all severities. And then in the proposed condition, by adding that paved shoulder in the centerline and edgeline rumbles, we got 6.394 crashes per year. And again, that's total crashes and all severities. So whenever we did the comparison of the percent reduction between the existing conditions and the proposed conditions, we found that you could potentially reduce your total crashes and all severities by 17.3% on a rural 2-lane road by paving a 2-foot shoulder and adding your centerline and edgeline rumble strips. And that is all I have for you today. I will take questions at the end.
Great. Thank you very much, Ashley. Appreciate that. Getting some really good real-world situations here. Constrained right-of-way, applying multiple countermeasures. Very good. And we're going to switch to another state presentation. This is Jeremy Fletcher from Florida DOT. And he's going to talk to us about some of the work that he's been doing using CMFs in design exceptions and a few other situations. So, Jeremy, I think it looks like we're seeing your screen, so you can go ahead and take the floor.
Well, good afternoon. My name is Jeremy Fletcher. I'm the State Quality Assurance Engineer in the Roadway Design Office at Florida DOT. One of our main office functions in the Quality Assurance section is the review and recommendation of design exceptions to the State Roadway Design Engineer. Today I'm going to go over some basic work processes and provide some examples for designers that use CMFs from the CMF Clearinghouse. Design exceptions should always be properly documented. These are the components for a properly documented design exception. My presentation will focus mainly on the safety and economic analysis portion of the process. Just recently, FHWA issued a memo to remind state DOTs and local agencies to consider design exceptions, helping to achieve a balanced design amongst the many competing priorities we face in designing state roads. MAP 21 has also added many state roads to the National Highway System. Effective October 2012, all these roads must meet NHS standards or have design exceptions approved. Meeting NHS standards means meeting all of the AASHTO and state-appropriate criteria for your local roadway. So what are design exceptions? This is FHWA's formal definition. A documented decision to design a highway element or segment of highway to design criteria that do not meet minimum values or ranges established for that highway or project. In other words, an engineering decision to design any one of the 13 critical elements below minimum criteria. A slightly more specific definition is provided in the P.S.M, stating that design exceptions are required when you can't meet either DOT or AASHTO criteria. Listed here are FHWA's current 13 controlling criteria for design. Safety analysis. Safety analysis is a process of reviewing both the nominal and substantive safety effects of a roadway to help in making design decisions. Today we're just going to cover some of the basics. FDOT uses two methods to analyze the safety of a particular roadway. One emphasizes a review of historical crash data. Another utilizes predictive equations such as those provided in the Highway Safety Manual. The historical crash method compares observed crashes over 5 years and determines which of those could possibly be attributed to a particular roadway condition. The justification should usually include more than one alternative considered in the BC analysis. One existing, one meeting criteria, and one maybe with partial improvement. The Highway Safety Manual can also be used to justify the approval of a design exception. The manual provides the ability to calculate expected crash rates using research-based SPS, safety performance functions, and CMS for alternative design benefit cost comparisons. Here's a spreadsheet we recently developed at FDOT to highlight which tools would be appropriate for the analysis of different types of design exceptions. This spreadsheet also helps designers determine what available CMFs or CRFs and equations are applicable and available for the 13 controlling elements. This matrix is available on the FDOT Roadway Design QA website. I'll take a few moments to highlight some important aspects of the matrix. You'll see the controlling elements in the same order that they are in the Mitigation Strategies Handbook published by FHWA. The column headings at the top are sorted by facility type and number of lanes. If there's a blue check, that means there's a possible application of the Highway Safety Manual. The number of available clearinghouse CMFs are provided in parentheses adjacent to the star rating associated with the CMFs. It is recommended that, and we recommend, one use CMFs with 3 stars or greater. These are all based on CMFs that were downloaded about a year ago completely from the FHWA Clearinghouse CMF database. In the far right portion of the spreadsheet, FDOT provides designers with CRFs developed specifically by our State Safety Office. These are developed based on before and after studies done on state projects using particular safety countermeasures. These are referenced by ID number in the far right column, as you can see here. For cross-slope, 0.3 to 0.33 is a CRF range that we suggest for use by the DOT QA office for use with those types of design exceptions. Now I'm going to cover a few things on the economic analysis. One of the most common economic evaluation methods is the benefit cost analysis. Step 1, the number of years of crash data. We require that you use a minimum of the most 5 recent years of crash data to begin your analysis. Step 2, determine the number of correctable crashes. Review the crash reports and determine the number of crashes that were directly related or influenced by the deficient roadway element. You can see the associated crashes attributable to different controlling elements in the Mitigation Strategies Handbook. There's some tables and discussions on each controlling element. Step 3, the total cost to society for each type of crash is multiplied by the number of correctable crashes. FDOT uses cost per crash as provided by the FDOT State Safety Office. These are used and combined with numbers from Federal Highway. Step 4, apply your select appropriate cash crash reduction factor. This estimates the crash reduction that would occur as a direct result of the proposed improvement. Available data and engineering judgment should be used to select appropriate crash reduction factors. You should match the CRF for your condition. Step 5, establish the benefit for correction of the condition. Your annual benefit will be the number of correctable crashes times cost per crash times crash reduction factor divided by the number of years of crash data. Step 6, calculate your costs. Estimate your construction costs to remedy the condition. Use a capital recovery factor to annualize your construction costs. Once you know the service life of your project or improvement and use a discount rate of about 4%, you can select your capital recovery factor from economic tables. Annual construction cost is calculated by multiplying each construction element by the appropriate capital recovery factor based on the interest rate and service life for that particular countermeasure. Then at the end, sum all of those costs to produce your total annual construction cost. And finally, step 7, calculate the benefit cost ratio. The VC ratio is computed by dividing the annual benefit by the annual costs. Next, I'm going to go through some examples using this economic analysis method we just reviewed. These are some that were prepared by design engineers working for FDOT. We felt like these provided some good examples for the use of CMFs from the FHWA Clearinghouse. First example is on a design exception at the I-95 Florida Turnpike interchange. During a recent RRR project to resurface some of the ramps, it was found that certain segments of shoulder width and horizontal clearance did not meet minimum AASHTO criteria. As you can see, it's a multi-lane interstate project. design speed of 35 and post speed 35 for the ramps. First, a comparison was provided of the criteria applicable to the condition. Existing conditions were 2-foot paved shoulders. DOT criteria requires 6-foot inside and out on ramps. AASHTO criteria requires 4-foot to 6-foot on the inside and out. Secondly, crashes were reviewed to determine if any could be possibly attributable to the deficient clearance and shoulder width. Using the mitigation strategies for design exceptions handbook, the crash types associated with these controlling elements were determined and looked for within the crash history. On one of the ramps, 2 crashes were found where the project engineer considered them to be potentially attributable to these conditions. Crash types we looked at were barrier hits, parked car hits, and fixed object strikes. To calculate the benefit, the FHWA clearinghouse was reviewed and CMF ID 3653 for shoulder widening was used. To calculate benefit, the average annual crash rate was determined and then adjusted by the CRF 0.36 to determine the annual crash reduction benefit. To establish the cost, the engineer produced an estimate and determined that it would take about $13 million to remedy the condition. The high cost reduced the bridge reconstruction that would be required. Using standard design service lives for the construction, the cost was annualized to be approximately $1.1 million. Dividing the benefit by the cost results in a BC ratio of 0.02, as you can see here. This helps justify leaving the deficient condition in place. Once the decision has been made to go forward with the design element below nominal criteria, the designer should look at ways of mitigating the condition. Mitigation is a way to reduce the risk associated with design exception. Mitigation measures may include providing advance notice to the driver of the condition, enhancing the design of another geometric element to compensate for a potentially adverse action, implementing features designed to lessen the severity of an incident, or some combination of these. FDOT requires a discussion of the applicable strategies considered in design exception documentation. In some cases, they should be included or may be included in the current design, but are not required to be included on every design exception. The MUTCD cautions about over-signing and the negative impacts it may have to the driver and or other signs. The next example is also in Miami. This design exception was prepared for a 1.7-mile triple R project on State Road 856, commonly known as the Lehman Causeway. The 6-lane freeway, design speed 55, post speed 55, with a low percentage of trucks. The design exception was prepared for 5 vertical curves, similar to the one you see here, that did not meet minimum AASHTO criteria for the design speed. Here's another one of the curves on the project that were deficient. Included in the documentation was a comparison of the applicable criteria. As you can see, the existing K values of 93 did not meet those values of 115 as required for SAG curves using a 55-mile-per-hour design speed. The same can be said for the K value for the crest of curve 2 and the remaining curves. The crashes on the project were reviewed, and 2 crashes were determined by the engineer to be potentially attributable to deficient vertical curvature. The crash type reviewed, the crash types reviewed were rear ends and other object collisions. To establish the benefit cost, the CRF was used from the FHWA clearinghouse of 0.4 for improving horizontal and vertical alignment. Applying this CRF to the average annual crash rate resulted in the annual benefit of $8,600. I'm going to go back a slide. There we go. To establish the benefit cost, the CRF, well, already have that. Oh, to establish the benefit cost, CRF was used. Oh, okay. Sorry. Let's go on the next one. To calculate the final benefit cost, We applied a 0.4 CRF to come up with an overall amount of crashes of 0.08. Multiplying that by the benefit gives you an $8,600 annual crash benefit. A good portion of this roadway was elevated bridge structure. To remedy these curves would have required extensive bridge reconstruction to the tune of $63 million. Once annualized at $3.3 million, this resulted in an overall BC of 0.00. This BC ratio helped justify leaving existing deficient curves in place. One of the mitigation measures mentioned in the report was the inclusion of lighting to increase stopping sight distance at night. Additionally, a right turn lane was added at one of the intersections to reduce other crashes on the project. Last project we'll review is the design exception for horizontal alignment and super elevation, also in Miami, Florida. This is a 1.3-mile triple R project, 4-lane arterial, design speed 40, posted speed 35. Two curves were found on this 5-lane arterial which did not meet minimum radii for the design speed of the roadway. As you can see here, here's the existing roadway, and here in bold you'll see the curve it would take to correct the deficient curvature. This was a triple R project meeting minimum radii values, would require reconstruction, would also have significant impacts to local businesses in the community. Here's a table that was provided for the existing alignment with some comparisons of applicable criteria. As you can see in this picture right here, stopping sight distance was significantly limited as drivers come around the curve. This particular design exception utilized the Highway Safety Manual. Safety performance functions were used from the urban arterial section of the HSM, and the CMF from the FHWA Clearinghouse was used to adjust the predicted crashes. Using the formula for a change in curvature from X to Y degrees, using this logarithmic equation here, CMFs were established for each of the curves. One was 0.73 after you plug in the degree of curve for each value. Plugging these values in the HSM worksheets below yielded that 11.71 crashes were reduced over the life of the project. Annualizing the cost for these 11 crashes and comparing them to the estimated annual cost to reconstruct results in a benefit cost of 0.56. This ratio helps support leaving deficient conditions in place. To help mitigate the condition, advanced warning signs will be added to warn drivers to slow down when approaching these curves. Additionally, new pavement friction will help counter the effects of deficient super elevation within these curves. Warning signs are proposed to be added to this project. Using appropriate CMFs and proper benefit cost processes are an essential part of the design process. I hope some of the examples I've provided you today will help you in your future decision making. This concludes my portion of the presentation. If you have any questions, feel free to give us a call. Thank you for your time.
All right. Thank you very much, Jerry. Appreciate that. Some perspective from practices and such in Florida. And we're going to switch control back to our screen over here. And we're going to go through some of the questions that have come up in the chat box for a few minutes here, and try to highlight a few of those. And if possible, get input from our presenters on those. So the ones, and I'll go ahead and mention that we won't be able to get to all the questions here, I don't believe, but we'll give a written compilation afterwards. I'll go ahead and address some of the ones that came up here. Someone asked about searching for CMFs on the clearinghouse site and whether they can be searched by a particular collision type as part of your initial search. It's a good question. I want to highlight just to kind of talk through a little bit about how the clearinghouse is organized. The entries in the clearinghouse are really organized by countermeasure and the CMFs for those particular countermeasures. That's kind of, if you were to think of files in a drawer, that's how it is, each file being the CRF associated with a particular countermeasure. That is the way that we structured the search for that. So when you search for something, you're getting results by search results, but you want to sort of narrow that down to say, I'm interested in treatments about a roadside effect, or shoulders, or some of these other ones that our presenters have talked about here. So that's how you have to go about that. You really need to search first by the on the countermeasure name itself, and then you can go to the details. If you have a particular collision type, for example, nighttime crash that you're interested in, you could possibly search for study abstracts, and certain studies may talk about nighttime crashes in their abstract, and that might produce some results for you if you want to try to search by collision type. It's just not what I would recommend as your go-to type of search to use. Let's see. Someone asked about, there's a couple questions that relate to basically how do you choose CMFs. I showed some examples in my demonstration about searching for various countermeasures and getting 5 or 10 or more CMFs under a particular countermeasure. And so a lot of times the question does come up, well, then how do I choose which one I'm going to use, especially if I'm seeing ones that maybe are similar in star rating. Maybe I see a couple that are 4-star, and they seem similar based on the first page I'm seeing there, so which one do I go with? I could offer a few words of advice here and then point you to something. So the one thing I'll mention, as I demonstrated, is that you don't see all the fields on the search results, and that's something to keep in mind. There's a few fields we put up in our search results, like crash type and severity and area type. You saw some of those in my demonstration. But keep in mind there are more fields that differ a CMF from another CMF. It may be about the traffic volume speeds of the roadway. It may be about the state where it's developed. So there are some differences that may arise, and you need to look at the details of the CMFs to tell the difference. For example, if Ashley were looking for a CMF on a particular treatment, and there's a couple ones that are presented to her in the CMF Clearinghouse, and the way they differ is that one was developed in Missouri and one was developed in California. She might prefer to have the one that was developed closer to her home area. So there are some reasons you might want to look at those details there. Certainly, if you are seeing CMFs that have different star ratings, I hope that will be a consideration for you. The star ratings are a way of telling you that we've gone through the study, we've looked at the various biases that the authors, the researchers considered, and how well they addressed and accounted for those biases, as well as how big of a sample was used to develop the CMF. And so larger samples get higher scores, that sort of thing. So there are criteria that we look at. If you're interested in those criteria, they are laid out in the Clearinghouse, the 5 different criteria that we examine, and sort of what leads us to give an excellent or fair or poor rating for each of those criteria. As well, you can look at any particular CMF that we've done a rating for and click to get the score details if you want to see a little bit more about how that particular CMF was scored and how it got to the 4, the 3, or the 5-star rating that it was at, whatever you're looking at there. Pardon me while I look through the questions here. I'll pick out another one here. There's some questions that have risen about kind of addressing some of those benefit cost examples that we've talked about and some of the presenters have run through. And one question is raising the issue of when you're looking at the cost side of the equation, when you're considering what costs are there. For example, Frank's example looked at installing a couple of raised medians, so sort of a narrow focus, whereas some of Jeremy's were much wider, looking at potentially reconstructing bridges and widening roadways and that sort of thing. So sort of what do you consider part of the cost? And the question is asking, do you consider right-of-way acquisition? Certainly, a lot of times, if you need to, for example, install a wider piece of pavement shoulder, putting a median in, something may trigger the need to have additional right-of-way that's not available at the time or not owned by the agency. And so right-of-way acquisition can be a significant cost. And the question is, do you include that cost as part of your benefit cost analysis? I think certainly it's up to the agency as to what they're going to consider to be part of their benefit cost analyses. As Frank mentioned, consistency is important, especially when you're dealing with states with multiple divisions or districts. I think from my own point of view, I would say that the costs that you're going to incur to implement a particular countermeasure would be the actual costs. And so it seems reasonable to me that you would include right-of-way acquisition as part of that. But again, that's a discussion to be had for the agencies and the way they want to sort of balance that question came up here about in the economic analysis, so another one related to economic analysis, and a really good question here about factoring in future AADT, either increases or decreases, but changes in the AADT during the service life. So, for example, some of the case examples that were run there, one from Frank's looked at a 10-year service life, and so the question is, when you're trying to calculate that benefit, do you factor in the fact that the ADT might increase on the facility, and you might see more crashes just due to the increased exposure on the segment or the intersection, what may be involved there. And so we didn't get into some of the more detailed benefit cost analyses and trying to predict the future benefits. When Frank mentioned, I think he used the term quick and dirty, looking at the past 5 years of crash history and kind of carrying that forward, that assumption forward for the next 10 years. That's a pretty simplistic way to go. It's a pretty quick way to use the past data to kind of predict your future performance. But I'll just mention, and we don't have examples that focus on this, but I'll mention that you can use crash prediction models, referred to often as safety performance functions, to aid you in predicting exactly what would you expect the performance of a piece of roadway or an intersection to be. If you do have access to the Highway Safety Manual, it has safety performance functions for a number of different facility types, such as two-lane rural roads or urban-suburban arterials. And that's something you could use to factor in the changes in the AADT that you'd expect, because those crash prediction models there have AADT as one of the major inputs, actually. So that's something to consider if you want to actually undergo more detailed analysis and be able to account for those types of volume adjustments. There's a couple of questions that are for some of our presenters exactly. And give me just a second, I'll pull some of those up. This is a question for Jeremy on SR 856, your example there. Specific question about the CRF used, and was it, I think they're just looking for some detail about, was that for target crashes or was that for total crashes? Because that can have an effect on the crash reduction that you're looking at. So if I could just have you speak to that real quick. This is for the SR 856 example that you had up there.
Yeah, the State Road 856, there were 2 crashes that were found to be attributable to deficient vertical curvature. In this particular case, the CMF that was applied, or the actually crash reduction factor that was applied to that one, reduced the attributed crashes to that particular condition, and that would be total. It's not really total crashes because it's not a highway safety manual analysis. It's only the number of attributable crashes based on the 5-year crash history, and it's but in a sense it's applying it to total crashes because that is the economic number that's used in the future benefit cost that's done later on in the State Road 856. So I hope that kind of answers the question.
Yeah, it's a good opportunity to mention the fact that certain CRFs are for total crashes. You know, those alls that I was showing in my example of the website. But some of them do focus specifically on target crashes, and that's important to consider. So, for example, the 2 CMFs that Frank was considering, or the 2 treatments, the one CMF he found was for pedestrian crashes specifically. So he was applying that only to the pedestrian crash history, whereas the other one was for all crashes, and so he was applying that to the all crash history. So, very good topic to consider in terms of doing the benefit cost analysis and looking, again, I'll be a broken record a little bit here, but looking at the details of the CMF is certainly an important thing. So thanks for that example there. The question, Frank, if you could address about the number of CMFs that you would advise using together in a sort of a combined analysis. You had given some examples where you're looking at 2. What about 3? What about 4? What would you speak to as guidance on that matter?
Yeah, that's a great question, and I think the Highway Safety Manual recommends applying no more than than 3 CMFs perhaps, and I think looking through the literature, that's fairly consistent with what most states have adopted or adopted. There are some states, I think, that will apply more than 3 CMFs, but I'd say once you get beyond 3, you're really increasing the potential for overlap within the treatments. You're increasing the uncertainty as well. So if you do have multiple treatments beyond 2 or 3, perhaps look at those effects individually, as I did with the pedestrian median refuge and then the other raised median there. So maybe try to separate out the CMFs if you have more than 3 for very specific crashes.
All right, thank you. And another question I think would be one I would send your way, Frank. The question is, what if the project is doing some intersection improvements, like adding an additional turn lane and adding a raised median? The location of the crashes is going to be different, intersection related versus other. Can you multiply and assume independence in this case? So the situation with adding an additional turn lane and adding a raised median, and I guess just asking about the independence in this case.
Yeah, that if both of the treatments were at the intersection, so if it was a raised median kind of within the functional area of the intersection, I would say that perhaps the CMFs could be multiplied if you determined that there was some independence there. But if it was a raised median along the segment or along a corridor, and then you were considering a left turn lane at 1 or 2 specific intersections along that corridor, I would tend to analyze the segment-related crashes separately from the intersection-related crashes, so kind of splitting up the crashes that are associated with a given intersection and then the segments that are between intersections, and kind of keeping those separate throughout the analysis rather than trying to combine everything at the same time.
Great. Thanks, Frank. I wanted to give a little bit more information. One of our participants wanted to give some additional input onto the acquisition of right-of-way. The question I mentioned earlier, I thought it was a good point to make that if you're going to be looking at including the cost of right-of-way acquisition, this would be a case where you really might want to look at lengthening your analysis period. So basically the amortization of that cost and looking at over a much longer period of time, since that is certainly a more significant upfront cost, and you really might want to look at the longer time frame in order to get a good present value of that. So I thought that was some good additional information put in there. Well, thank you for all the questions, and I think this is all the time we have to get to them here, but again, we'll put the written compilation out and put that with the materials that we'll post later with the recording of the webinar. So I'd like to go ahead and give it back to Karen Scurry to wrap us up here.
Great. I just want to take a minute to thank you, Daniel, as well as Frank, Ashley, and Jeremy for taking time out of your busy schedules to be online with us today and share your expertise and experiences with us. There was lots of great information about the application of crash modification factors, some good guidance, and some practical examples of how at least 2 state DOTs are applying CMFs in their day-to-day activities. If you like what you heard today, I would encourage you to take a look at the CMFs in Practice series. It's very similar in that there are a series of guides that show you how to apply crash modification factors in various activities, including road safety management, road safety audits, the development and analysis of alternatives, design decisions and exceptions, as well as value engineering. Each guide provides step-by-step instructions for applying CMFs, as well as at least 1, in some cases 2, case studies that demonstrate real-world applications of crash modification factors in each of those activities. The series of guides are available on the CMF Clearinghouse website in the what do you call that, Daniel? The scroll thing on the home screen, and will soon be added to the resources section. Say it again.
The rotating banner on the front page.
There you go, the rotating banner on the home page of the CMF Clearinghouse. So please take a look at the CMFs in Practice series. There's lots of great information in there to help you apply CMFs in many of these activities. Just a couple of wrap-up housekeeping items. When you exit the webinar today, there will be a brief survey that will automatically load. We would very much appreciate your feedback on our performance today. We do look at this. We do consider your feedback. That's how we came up with the topic and the presentations for today. So please complete that survey. Either tomorrow or Wednesday, you should receive a follow-up email with a link to download a printable certificate of attendance for 1.5 hours of instruction. If there are multiple attendees at your site, you can forward this link to those participants so that they can download and print the certificate with their name as well. I mentioned earlier, and Daniel reiterated, that we will post a recording of today's webinar along with a transcription of the questions and answers, including those that we weren't able to get to during the webinar today, on the CMF Clearinghouse website, and I'll say within the next week or so, but give or take a couple of days given the holidays are there. We're right at 3:30, and I did want to conclude with a thank you to all of you for joining us today. I know we all have busy schedules, and we appreciate you taking the time to sign on and learn more about crash modification factors. So thank you, and have a safe and happy holiday.